This is called a radical, right? And the number that is underneath the radical, that is called the radicand. Okay, so you guys might see this coming up in the ACT and all that stuff. You might hear the term radical and radicand. Okay, so number one, it's asking us to find the square root of each number. It's asking us to round our answers to the nearest hundredths place. So the hundredth place is 2 places after the decimal. Okay, so when working through these, we can go ahead and talk a little bit more about the rules when we are rounding. Okay, so like the first one, right? The first one, it's asking us to go and round radical 12. So I'm going to go to my calculator. And in our calculator, on the bottom, there's the radical symbol. And then I'm going to type in 12. And it looks like we have about 3.4641, yada, yada, yada. Right? It goes on and on and on. Okay? We have to go and round to the nearest hundredth, so 2 places after the decimal. So when we are rounding, we're going to look at 2 places after the decimal. So right here, right, we're trying to see if we are going to round the 6 or keep it the same. The way that we know is that we are going to look at the next number on over. If it's 5 or above, we round. If it's less than 5, then we do not round. Right, 4 is less than 5, so I don't even pay attention. Your answer is 3.46. Okay. Same thing, let's try the radical of 27. Oops. Right, that gives us 5.19615 dot 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 dot. Right, same exact thing. I'm round to the nearest hundredth, so 2 places after the decimal. So I'm looking to see if I round up the 9. Right, same exact process, guys. I'm going to go ahead and look at the next number over. 6 is more than 5, so we do round up the 9. Right, when we round up 9, we go one more, right? So one more would be 10. So it really happens if I have 5.20, right? 5.20. Okay, the next two examples, we're going to do the square root of 25. So the square root of 25 is actually a nice number. It's equal to 5. That makes sense, right? The reverse of a square root is squaring. So I know 5 squared is equal to 25. So that checks out. Right, then the next one is the square root of 144. And that does give us a nice number. It is 12. Makes sense if I take 12 squared. Right, it also gives me 144. So it all checks out there. Okay. All right, so let's go ahead and talk about our right triangles. So it's asking us, what are the parts of a right triangle? Our right triangles, guys, these are our 90-degree angles, right? Angle triangles. Right, we've talked about these before. So in a right triangle, the sides that form the right angle, so the sides that form the right angle are called legs. They're the legs of the triangle. Right, so I'm going to look at the two sides that form the right angle. Here we go, right? These two sides form the right angle. So here's one leg, here's the other leg. Okay, and then it says the side opposite the right angle is called the hypotenuse. Hypotenuse. It's a weird word. Go and try saying it. Hypotenuse. Okay, so the side opposite of the right angle, so here's the right angle, opposite to the right angle is this side of BA, and this is called the hypotenuse. Okay. Now, when looking at a triangle, and we're going to see this a little bit later, is that the angle related to the side, so this one's angle A, So then this is going to be side A or leg A, right? Same thing. Here's angle B. The side that is across from angle B is going to be leg B or side B. Same exact thing. I have an angle C. The side across from angle C is going to be side C. Okay. All right, so let's go ahead. So you can find the length of missing sides, right? We've talked about scalene triangles. We've talked about equilateral and isosceles, right? There might be times where in a right triangle, specifically a right triangle, you can find a missing length, right? And you can find a missing length using what is called the Pythagorean theorem. So go ahead and try saying Pythagorean. 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 Okay, so Pythagorean theorem, remember theorem is just a nice rule in math, but it says in a right triangle, the square of the length of the hypotenuse, so in this case the hypotenuse is side C, is equal to the sum of the squares of the lengths of the legs. And this is going to be leg A and leg B. Okay, what happens is this, all these bolded words, guys, it just means this, is I'm going to have leg squared plus leg squared is equal to the hypotenuse squared, right? So if I'm looking at my angles, here's angle B. Across from angle B is side B. Right, here's angle A. Across from angle A is side A. Right, here is leg B. Here is leg A. And then across from my right angle, that is my hypotenuse, side C. Okay, so I'm going to take leg A squared, plus leg B squared is equal to hypotenuse squared, which is C squared. Okay, this is what we have to go ahead and start being aware of, is I have A squared plus B squared is equal to C squared. Okay, so let's go ahead and try some problems on the next page. All right, it says example 1, find the length of the hypotenuse C, right? So this triangle is not really labeled, but let's go and label it. All right, so across from angle B is side B, across from angle A is A, and we see that across from angle C is side C. Right, so I'm going to go and set it up. I'm going to use my equation, A squared plus B squared is equal to C squared. And then I just plug it in, right? A is equal to 21, B is equal to 20. We are trying to find B. Okay, so I'm going to take A squared, which is 21 squared, plus B squared, which is 20 squared, and I'm going to equal it to C squared. From here, guys, all we're doing is just solving, right? So in your calculators, let's type in 21 squared, right? 21 squared means 21 times 21, right? So this becomes 441 plus, now I have 20 squared, which is equal to 400, is equal to my unknown of C squared, right? From here, we go ahead and solve for C. Okay, from here I can go and combine. Let's combine 441 plus 400. All right, that gives me a value of 841 is equal to C squared. Right, just like I said before when we were doing radicals, is a radical is the opposite of squaring. So when we have squaring, we want to go ahead and take the radical. We want to take what is called the square root, right? So from here, this means C squared means C times C, but I only want one C. So to take away that squaring, right, the C squared, I'm going to go ahead and square root both sides. That is like the most important thing. Right? If I take the square root of C squared, what pops out is C. Okay? And in my calculator, I'm going to type in the square root of 841. and that gives you a value of 29. So 29 would be your answer for C. Okay, this is the last step, is when you have c squared, you got to automatically think, okay, let's go ahead and take the square root of both sides. Okay, so let's go ahead and try example 2. Right, same exact thing. I'm going to go and label the triangle. Here's A, here's B, here's C. Across from C is little c, that's your hypotenuse. Right, across from A is little a. Ooh, you know what? Scratch that, sorry guys. Okay, here's little b, right? So across from B, that is going to be angle B. So, right, here's C and here's A. Right, across from A is side A, and across from angle C is hypotenuse C. Right, so here we go. We have A squared plus B squared is equal to C squared. The A we see is 6. We are trying to find B. We know that C is 10. So A squared becomes 6 squared plus B squared, that's what we're trying to find, is equal to C squared, which is 10 squared. Again, here we go and solve. Right, so I can go and compute. Right, 6 squared, or 6 times 6 is 36, plus my unknown of B squared. 10 squared, or 10 times 10 is 100. And then here, right, you're solving for B. So I'm going to go and subtract 36 on both sides. I get B squared is equal to 100 minus 36, gives me 64. And again, this is where it comes into time. Okay, I have B squared. I need to take away one of the B's, right? I have to go ahead and take the square root of both sides. From here, I'm going to go and take the square root of both sides. So really, you're trying to solve the square root of 64, and that gives you a value of 8. So here is the answer. Okay, I want you guys to try example 3 and example 4. So go ahead and press pause and try those 2 examples. All right, guys, let's go ahead and try example 3. So find the length of leg B. Right, so here's leg B. Opposite of leg B is angle B. So here's angle B, angle C, and angle A. So then across from angle A is side leg A, and across from angle C is your hypotenuse C. Now, once you guys get into practice of this, you will be able to set it up just like we've been doing, right? So I'm going to go and get started. I have A squared plus B squared is equal to C squared. So A is 12, so this becomes 12 squared plus B squared, that's what we're trying to find, is equal to 13 squared. Right, then we're going to go and solve. Right, 12 squared. That gives me 144. Plus my unknown of B squared is equal to 13 squared, which is 169. From there, I'm going to go and subtract 144 from both sides. B squared is equal to 169 minus 144. That equals to 25. And again, we run to this problem. Okay, I have 2 B's, right? I need to get rid of one. So I'm going to take the square root of both sides. And all I'm typing in is the square root of 25. That gives me a B value of 5. Okay. Same thing with example 4, right? I'm going to go and start labeling my triangle. Across from B is angle B, right? Angle A, so this becomes side A, and then angle C, this becomes hypotenuse C. Okay, so same thing, I have A squared plus B squared is equal to C squared. So A squared, this is 4 squared, plus my unknown B squared is equal to C squared, which is 5 squared. Okay, from there, let's go and get solving. 4 squared is 16, so this becomes 16 plus B squared is equal to 5 squared, which is 25. And then I can go and subtract the 16 on both sides. Becomes b squared is equal to 9. Same exact thing. I need to take the square root of both sides. So then the square root of 9 gives me an answer of 3. So b is equal to 3. Okay. At this point, I'm going to go ahead and create a new video for example 4.